over to you now.
Kelly, thank you so much. And thank all of you for joining us this afternoon. I hope your day is going well. Today we'll be presenting on how to navigate the ASHRAE Epidemic Task Force resources to help us understand better designs for HVAC systems and perhaps even building practices to create healthier environments in the occupied space. As Kelly mentioned, my name is Dan Hani, and I've been in the industry for a number of years. I am currently, I work at Veritech. As a senior sales engineer, a position that I took in 2016. My background is a little unique. My education started off in engineering at the University of Arizona, where I studied 2 years in chemical engineering, and then I had a change of direction in my life. I discovered the arts, and I decided that I was going to become an artist. And back in the 70s, you could be adventurous. I bought a one-way ticket, flew to London, and to make a long story short, I ended up with a degree at University College London, one of the University of London degrees, or colleges. From UCL, I went on to get my master's in sculpture at Boston University before accepting a job as estimator at Norman S. Wright. I actually earned my way through college working at a sheet metal shop called Metal Form Manufacturing. Some perhaps Phoenix individuals might recognize the name of Metal Form, where I built industrial sound acoustical plenums. And so that was how I got into the industry. And when I graduated from BU, Norman Wright reached out and asked if I wanted an estimating position. I said, sure. And that's where it all began back in 1985. I moved into sales, and then in 2000 joined Air Specialty Products as their first outside salesman. From there in 2008, moved into engineering sales. When I moved into engineering sales, I wanted to do something a little different. There was a growing momentum for high performance HVAC designs, and I decided that this is the direction I needed to go, and this is the direction the industry is going. And history has proven that to be the case, certainly with the advancement of standard 90.1. So I became a resident expert, you could say, in chill beam technologies, underfloor air systems, displacement ventilation, low pressure VAV, anything that could drive out any kW from the HVAC system. In 2016, Veritech and I joined forces, and they brought me on as their educator. And this is where I've been ever since. And I must say, it has been wonderful working at Veritech, because they just give me so much breadth and latitude to pull whatever resources I need to in order that I may become, and Veritech may become, an engineering resource for our design community as our standards continue to advance and develop. Today's presentation is going to cover a multitude of items, and we're going to have to be a little dense and a little fast because there's just so much material to cover, but I'll try to stay focused and stay on task. First of all, I'm pleased to say that this presentation is the launch pad for our new Veritech Technical Institute. We are expanding our educational resources into a program, and that program will continue to unfold and develop from previous presentations. So we're able to expand on topics drawn from industry-leading standards, reports, scientific studies, etc., and bring this information into our market today. Then we're going to look at the SARS-CoV-2 discussion and the evolving position. We're going to look at ASHRAE's Epidemic Task Force, and then how to navigate the task force site, as it is simply because there's so much data. I think ASHRAE's done a terrific job, but it can be a little confusing where you might go to find what relevant topic you need to assist you in your design considerations. We're going to look at the ASHRAE statement. We're going to look at and study the position documents. We're going to look at core recommendations, and then just give you some navigational guidance on the building readiness functionality of the interactive PDF generated from the website, as well as building guides. So Veritech, first of all, Veritech, I would like to introduce to some of you, or many of you perhaps who haven't joined us before, is an integrated HVAC system solution provider. We've been in the industry for over 40 years now and span from Southern California eastward to Western Texas. And we can work with heating and ventilating systems in all types of construction, from healthcare, education, data centers with our Munters data center line, hospitality industry, government, small businesses, etc., even custom homes. We can look at these projects and look at it from an integrated system and not necessarily merely as a manufacturer component. So we think that offers value because if you have a holistic approach, you understand, I think, better how to optimize that system to make it as efficient as possible and to perform as the owner would like it to perform. So we can help our engineering and our build community on variable refrigerant systems, mixed air VAV systems, packaged central plants, both air and water cool designs, cloud-based controls for small and medium sized buildings, especially for variable refrigerant solutions and packaged DX equipment, humidity control, underfloor air systems. We work regularly with design teams on 100% outside air systems, which is very important today as ASHRAE advocates for more ventilation in our buildings. We could look at DOAS technology, active chill beams, passive hydronic, radiant cooling and heating systems. All of them we can help participate in, providing a design team with an integrated approach to optimize system performance. And as always, Veritech has inspired me to continue looking into the future. Where's the industry going? So I regularly look at the latest standards of ASHRAE. What does standard 90.1 have to say? What does ASHRAE standard 170 for healthcare have to say in the latest publication of 2017? So our mission statement at the Veritech Technical Institute is to provide an educational platform for continued learning in the HVAC industry with a focus on high performance buildings and interactive technologies for a better built environment. And I'm pleased to say, and I believe, and I think history has proven that if an integrated effort is put forward in using high performance solutions, an owner may not need to pay a premium first cost if we take full advantage of the building opportunities the owner and the architect has before them. So be aware of that. To demonstrate our committedness to the Technical Institute, we have a multiple series webinar Wednesday program that will build from what I'm covering today. I'm not an advocate of doing a kaleidoscope of various presentations. I think you've got to make sure that any presentation is tied in to a fundamental reason, and that reason is often given to us by ASHRAE. And that's what we want to use as our baseboard. That's what we want to use as our foundation, and to see how ASHRAE's recommendations expand into each of the technologies we have before us today. I just want to introduce you, especially for the presentation we're providing in 2 weeks. I've been working with a team on doing CFD modeling on pathogen migration in the space when you evaluate air distribution technologies available. And we have some interesting resources that I'm going to present on an hour on the physics of pathogen migration, or how viruses and germicides travel in the built environment under various conditions and what influences that travel. So stay tuned for that. Another hopefully exciting, well, this one will be exciting, is the ASHRAE 62.1 presentation. We have Hoy Bohannon, a distinguished lecturer from ASHRAE, who will be presenting on 62.1. So thank you for your time. Well, let's move into today's presentation. And before we do, let's understand the political climate that has unfolded over the last few months with the development of our understanding on how SARS-CoV-2 or COVID-19 is transmitted. Initially, the World Health Organization and the CDC appropriately advocated phlebitic transmission, which is surface to surface or hand to mouth, or large droplet transmission of contaminant released from an infected agent to within the 6-foot distancing guidelines of that person. That was the common understanding of how historically the COVID-19 was transmitted. However, on August 25th, an article written and published in Time magazine challenged this conventional wisdom. And the name of the article was COVID-19 is transmitted through aerosols. We have enough evidence. Now it is time to act. And it stated, contrary to public health messaging, I, together with many other scientists, referencing Professor Jose Luis Jimenez from the University of Colorado, Boulder, I, Professor Jimenez, together with many other scientists, believe that a substantial share of COVID-19 cases are the result of transmission through aerosols. There are 3 possible ways the virus is transmitted, of which 2 have been emphasized by the World Health Organization and the CDC: phlebitic transmission, droplet transmission, specifically large droplet transmission, and aerosols. The article then went on to challenge the WHO and the CDC by making this statement: while the WHO and the CDC both state that aerosols could lead to transmission under highly specific situations, both organizations maintain that they are less important. Professor Jimenez goes on to state, or went on to state, I believe this is a significant mistake. I, along with 239 scientists, appealed to the World Health Organization to reevaluate their stance. The WHO did do so with language that was less than effective, according to Professor Jimenez. Anyway, Professor, I'll have you know the impact of the debate of the scientific community with the public announcements of the WHO and the CDC resulted in the CDC on October 2nd acknowledging that COVID-19 can sometimes be spread by airborne pathogen. Some infections can be spread by exposure in small droplets and particles that can linger in the air for minutes or hours. And that was a big shift. These viruses may be able to infect people who are further than 6 feet away from the person who is infected, as demonstrated by the scientific findings from the Guangzhou restaurant in China that occurred early in the summer. This kind of spread is referred to as airborne transmission. Well, ASHRAE, the CDC's current language I just peeled off today, has expanded upon that awareness that airborne transmission of SARS-CoV-2 is a likely means of transmission and should be evaluated. Well, what does this mean in relation to ASHRAE's Epidemic Task Force? In April of 2020, ASHRAE opened their Epidemic Task Force. And if you go to the ASHRAE website, you can access all the resources from this task force from the main home site of ASHRAE. If you scroll down from the cover photo shown here, you'll arrive at the Coronavirus COVID-19 Response Resources from ASHRAE and others link. Click on that, and that'll bring you to a group of links: the guide to the COVID-19 pages, the core recommendations for reducing airborne infectious aerosol exposure, questions or frequently asked questions and questions. All of these are available if you click on them from this coronavirus response resource. So let's have a look at what ASHRAE was saying back in April of 2020 in their statements and position documents on infectious aerosols. I think you'll see that ASHRAE was very much and eminently above the common wisdom. If you go to the ASHRAE.org COVID-19 tab on the ASHRAE Epidemic Task Force PDF link, It's really pretty interesting. If you click on the link, I'll show you here. Just click on the page here. This actual PDF will open up. It should open up. And it's from here that when you click on them, independent PDFs will open up with the various guidelines. It's actually very, very resourceful, very easy to use, and you can immediately download as PDFs those documents to your own files so you have them personally. So if you go to the link called the ASHRAE.org COVID-19, you will arrive at the ASHRAE statements. And the ASHRAE statements are very, very clear over, well, gosh, we're going on 10 months ago on how HVAC systems could influence the transmission of SARS-CoV-2. If you click on the statement, there's a quote that says, ventilation and filtration provided by HVAC systems can reduce airborne concentration of SARS-CoV-2 and thus the risk of transmission through the air. If you click on the position documents, you'll arrive at the ASHRAE position document on infectious aerosols. And we're going to spend a little time on this because from here we can actually set up a foundation that allows us perhaps to better understand why we have the recommendations and guidelines promoted as for building readiness programs, the reopening of schools, and all of these other issues. So we're going to study this in a little more thoroughly than the other documents. The position document on infectious aerosols have various categories. We have the issue statement, a background, airborne dissemination, varying approaches for facilities, ventilation and air cleaning strategies, temperature and humidity, emerging pathogens and emergency preparedness, and then, of course, the conclusions arrived at the end of the document. First of all, looking at the abstract, ASHRAE is very clear that some diseases are known to spread by infectious aerosols. And it goes on to state the risk of pathogen spread can be affected both positively and negatively by the airflow patterns in the space and by heating and ventilating and air conditioning and local exhaust ventilation systems. The executive summary goes on even further to state HVAC systems, however, do impact the distribution and bioburden of infectious aerosols. This position document covers strategies through which HVAC systems modulate aerosol distribution and can therefore increase or decrease exposure to infectious droplets, droplet nuclei, surfaces, and intermediary fomites. The issue, well, ASHRAE is very clear about what the issues are, and it clarifies its position by stating the potential for airborne dissemination of infectious pathogens is widely recognized. Transmission of disease varies by pathogen infectivity, reservoirs, routes, and secondary host susceptibility. In other words, the effective transmission of a virus depends on a multitude of factors. You can have a low dosage received by somebody with an immunocompromised system who can be infected, or you could have a large dosage with somebody who's in excellent health not be infected. It's very hard to offer a clear-cut matrix as to what concentration of pathogen will result in active infection. This issue statement goes on to say the variable most relevant for HVAC design and control is disrupting the transmission of pathways of infectious aerosols. So let's look at the background here. Airborne dissemination. ASHRAE states pathogen dissemination through the air occurs through droplets and aerosols typically generated by coughing, sneezing, shouting, breathing, toilet flushing, medical procedures, singing, talking. All of these factors are expiratory events of pathogen in the space from an infected agent. And the actual physics behind each of those modes of expression will be covered in the physics of pathogen migration presentation in 2 weeks. Well, regarding airborne dissemination, ASHRAE goes on to say small aerosols, which can stay airborne and infectious for extended periods, minutes, hours, days, and that's a big one, days, and thus can travel longer distances and infect secondary hosts who had no contact with the primary host. While ventilation systems cannot interrupt the rapid settling of large droplets, and we'll cover that in greater detail in the future, they can influence the transmission of droplet nuclei infectious aerosols. So that's an important distinction. How your HVAC system conditions the air, delivers the air within the built environment can influence transmission by droplet nuclei viruses that could be concentrated within the space. ASHRAE goes on to say the majority of larger emitted droplets are drawn by gravity to land on surfaces within 3 to 7 feet from the source. And that falls right in line with the CDC 6-foot social distancing guideline. It works. ASHRAE goes on to say general dilution ventilation and pressure differentials do not significantly influence short-range transmission. In other words, particles of 100 microns are going to precipitate out, and there's nothing you can do with the HVAC system that's going to impact or mitigate the risk of transmission from that source within the 6-foot social distancing guidelines. However, ASHRAE says, conversely, dissemination of smaller infectious aerosols, including droplet nuclei, which we mentioned, as ASHRAE mentioned, can stay airborne for minutes, hours, or days. Droplet nuclei resulting from desiccation, and we'll cover that in more detail in future, can be affected by airflow patterns in the space in general and airflow patterns surrounding the source in particular. So what are the practical implications for building owners, operators, and engineers? Well, ASHRAE offers these guidelines that the minimum a building owner should be considered, should take seriously and consider is to make sure that their building is being served by the ventilation rate as outlined in ASHRAE standard 62.1, 62.2 for residences, and 170 for healthcare facilities. However, ASHRAE does not provide specific requirements for infectious disease control in homes, schools, prisons, shelters, or any other public facility. So be aware of that. So what we have to lean on with regard to commercial buildings is applying appropriately ASHRAE standard 62.1 for the required ventilation air to get to the breathing zone of the occupants. The varying approaches advocated by ASHRAE for facility types, though, goes on to recognize their statements on healthcare facilities and how they use what they call multiple modalities simultaneously to create what are called infection control bundles. And from ASHRAE's incorporation of this language into the position document, I believe what ASHRAE is saying, that building owners consider adopting healthcare infection control bundles for other types of buildings. What do I mean by that? Well, we'll explore it in greater detail shortly, but why not use infrared lighting or enhanced filtration? Why not use more ventilation air if your HVAC system can handle that? Why don't you use a blended approach? Because there's no absolute cure-all to prevent the risk of transmission. But the more safety nets you put in place, the less chance of transmission can occur within that building. That's the way I take ASHRAE's direction in their position document. In the ventilation and air cleaning strategies category, it goes on to say that ventilation with effective airflow patterns is a primary infectious disease control strategy through dilution of room air around a source and removal of infectious agents. However, it remains unclear by how much infectious particle loads must be reduced to achieve a measurable reduction in disease transmission. So again, infectious doses of pathogens vary widely depending on the pathogen that is being communicated. It depends on the infectivity level of the recipient of that agent, whatever. So it's a little bit of it is an approximation of what the infectivity rates could be. The ventilation and air cleaning strategies then goes on to advocate these strategies to reduce the risk of infectious aerosol dissemination. Look at air distribution patterns, differential room pressurization, personalized ventilation, source capture ventilation, filtration, controlling temperature and humidity, and ultraviolet germicidal radiation, or UVGI. ASHRAE goes on to express the importance of proper temperature and humidity control. Controlling relative humidity reduces transmission of certain airborne infectious organisms, including some strains of influenza. This position document encourages designers to give careful consideration to temperature and RH. And these studies show, by the Taylor and Tazi study done for ASHRAE in 2018, the conclusions from that study showed that relative humidity below 40% is associated with 3 factors that increase infection. Infectious aerosols emitted from a primary host shrink rapidly to become droplet nuclei, otherwise known as desiccation. Many viruses and bacteria are anhydrous resistant and will thus survive and thrive in drier environments than more humid environments. And relative humidity levels below 40% inhibit our human immune system from operating effectively to remove any ingested pathogen that we may have come in contact with. ASHRAE goes on to state that emergency pathogens and emergency preparedness awareness. It states disease outbreaks, epidemics, and pandemics are increasing in frequency and reach. Novel microorganisms can be disseminated by infectious aerosols, necessitate good design, construction, commissioning, maintenance, advanced planning, and emergency drills to facilitate fast action to mitigate exposure. Well, the conclusions and recommendations from the position document are these. Various strategies have been found to be effective at controlling transmission, including optimized airflow patterns, directional airflow, zone pressurization, dilution ventilation or increasing outside air, in-room air cleaning systems, general exhaust ventilation, personalized ventilation, local exhaust ventilation at the source, central system filtration, UVGI or ultraviolet light technology, and the controlling of indoor temperature and humidity. Design engineers can make an essential contribution to reducing infectious aerosol transmission through the application of these strategies. So ASHRAE is very clear. So how do we navigate the guide to COVID-19 pages so that we get the information that we need? Well, first of all, the 30,000 foot elevation on core recommendations is available on the PDF. The core recommendations offer the following categories of guidance: public health guidance, how to lay out ventilation, filtration, and air cleaning systems. Well, not how to lay it out, but what to be aware of. It goes into air distribution, HVAC system operation, and of course, a big one that we might not be paying much attention to is system commissioning. Well, the public health guidance states follow all regulatory and statutory requirements and recommendations for social distancing, wearing of masks, and other PPE as advocated by the CDC. That is a no-brainer. The ventilation, filtration, and air cleaning offers these concise guidelines. Provide and maintain at least required minimum outdoor airflow rates for ventilation as specified by applicable codes and standards. Use combinations of filters and air cleaners that achieve MERV 13 or better levels of performance for air recirculated by HVAC systems. Only use air cleaners in the space that have evidence of effectiveness and safety records and have proper listings. Select control options, including standalone filters and air cleaners that provide desired exposure reduction while minimizing associated energy penalties. And that's a consideration with your system. As many of you are aware, if you enhance your filtration, you will increase your system static pressure to your air handler, providing air to a building. You need to evaluate whether or not the horsepower and fan sizing of those units are enough to overcome the added static pressure that results from this enhanced filtration. Air distribution, one that do we really consider very carefully. ASHRAE advocates as a core recommendation that where directional airflow is not specifically required or not recommended as the result of a risk assessment, promote mixing of space air without causing strong air currents that increase direct transmission from person to person. The illustration shown here suggests, well, what about displacement ventilation? In my mind, it seems to conform completely with ASHRAE's core recommendation on air distribution. HVAC system operation. Maintain temperature and humidity design set points in the space. Maintain equivalent clean air supply required for design occupancy whenever anyone is present in the space. It also offers guidelines on when it is necessary to flush spaces between occupied periods. Operate systems for a time required to achieve 3 air changes of equivalent clean air supply. Limit re-entry of contaminated air that may re-enter the building from energy recovery devices, outside air intakes, and other sources. And then, of course, number 5 is system commissioning. Do we have a means of testing out, per the checklist that ASHRAE actually does provide in the recommendation guidelines for the reopening of buildings? Are these systems operating? Is the outside air damper opening up to make sure that the building is getting at least the minimum outside air as prescribed by ASHRAE Standard 62.1? That's a big one. Are filters being properly changed out at a regular time interval? All of this should be covered under system commissioning to make sure the existing HVAC system is performing per the design intent in conformance with the standards. So how do we navigate these pages? How do we actually surf through a dense resource of material that can be very difficult? Trust me, I know, I've done it. Anyway, I advocate that if you go to the Guide for COVID-19 pages, you look at the building readiness area, and there you'll find different categories. You'll find the epidemic positions in place. This is like the master document, of which many of these other links go to a section on that master document published here. So this is the one you want to look at to study for practical methodologies for securing your building in a way that will reduce the risk of infection. On the opposite side is a post-epidemic positions in place. Again, a very important document that is linked to the epidemic positions in place. You want to look at, there's a section on building automation systems. There's a section on energy recovery, outdoor air, UV light technology, filtration, and a big one, maintenance protocols and prescriptions. So what is the epidemic positions in place readiness intent or building readiness intent state? The following building readiness information is meant to provide a practical information and checklists. And those checklists are there. And I highly advocate you look at them if you're a building owner to make sure that your system is operating appropriately. And checklists for how your building should be operating and how to practically check its operations. The Building Readiness Guide also refers you to practical guidance on operating of building systems in various different modes: healthcare, residential healthcare, commercial, schools and universities, etc. And we'll look at that in greater detail shortly. Oh, and by the way, if you go to Building Readiness, you'll find all of the relevant topics included within that document. If you click on any of those items, it'll take you right to the section of the PDF you need to go to get that discrete bit of information. The Building Readiness Intent goes on to state that controls and system evaluations to be evaluated. Just a handful drawn from this paragraph, or this listing, I've included here on the left: the ventilation per code design, increased ventilation guidelines, pre or post occupancy flushing, upgrading and improving filtration and what is involved in that, filter droplet nuclei efficiency with regard to MERV filtration listings or certifications, UVI systems, et cetera, et cetera, et cetera. All of them are laid out here and are inclusive in that and that epidemic positions in place guideline, offering you guidance for each of those topics. The Building Readiness Intent goes on to say that it offers specific recommendation from the building guidelines, such as how do you do system analysis? How do you evaluate your ventilation? Are you getting the adequate ventilation to the space? How do you do increased filtration? How do you calculate the duration of flush modes so you evacuate any buildup of pathogen concentrations through the occupied hours? It looks at energy recovery ventilation system operation and any potential for exhaust air reentrainment. If you want to know more about energy recovery, if you have energy recovery on your building and you click on the energy recovery link, it'll take you to its own discrete PDF page that you can download. And it is expansive. I believe that's why ASHRAE dedicated a full PDF page to that recommendation. We don't have time to get into what that might be. And to be honest, I haven't really studied it myself. But if you need to, then it is available at the task force website. It has an outdoor air link. It can give you guidelines on what your outside air needs to be and whether or not you have the capacity to provide, as ASHRAE would advocate, more outside air, perhaps than 62.1 might recommend as a minimum. So this is a part of the readiness document. So if you click on that tab, it'll just take you to the master PDF document. It gives you guidance on how to apply ultraviolet light technology in your space, whether it's in an air handler or within the built environment itself. You could argue if you need a fast, immediate technology to create a healthier environment, in-room UV light generation might be a suggestion. And we'll cover that in greater detail in a future presentation, future webinar. Filtration. There's quite a lot that the building readiness guidelines have to say regarding upgrading and improving filtration. What are the considerations? How do you decide based on a loaded filter what sort of anticipated added static pressure might be incumbent upon that system and whether or not you have the capacity in your air handlers to meet those requirements? And it gives you prescriptive readiness guidelines for how to maintain a building to make sure the system is always operational in accordance to design standards, to make sure that the amount of air is necessarily being delivered to the space, the amount of ventilation air is being delivered to the space, and purge cycles are properly scheduled and occurring to evacuate pathogen concentrations that build up during the occupied hours. And then there's the building automation system section. ASHRAE says it is crucial for the owner to understand the type of BAS they have in their building HVAC controls. Why? Well, the building automation system is the mothership of your building HVAC system performance. So you want to make sure that your BAS is operating properly and that it is controlling the system in a way that ASHRAE's standards and design intents are being met. Then there's another separate link from the building readiness that is called filtration and disinfection. Here's a listing of all the topics that fall under that link. And here's just to mention a few in the filtration resource list: modes of transmission, airborne transmission of pathogen, HVAC system maintenance and filter replacement. What is minimum efficiency reporting value, or MERV, that defines our filtration effectiveness? There's also passages on disinfection strategies, such as in-room HEPA filter air cleaners. What about ultraviolet energy and light technology and application? There's a statement on bipolar ionization and corona discharge technology, using ionization to create better indoor air quality and healthier environments by neutralizing pathogens in the space itself. And then what is ASHRAE's position on needlepoint ionization? All of that is available in the filtration and disinfection section. Just recently in December 2020, I want to bring to your attention, however, if you're looking at filtration or optimizing filtration to reduce the concentration levels of pathogens in your building, there's an article on Understanding Standard 52.2 that wrote the MERV standards for filtration effectiveness. And ASHRAE states, one of the lines in that article is, large efficiency increases such as those seen with ASHRAE dust, which is how MERV ratings were established using ASHRAE dust. In ASHRAE standard 52.2 were not seen for in situ filters. Research project 1360 showed that filters that look very dirty and caught substantial dust can have much lower efficiency than clean, or, you're gonna love this, have somewhat higher efficiency. So it's just be aware there's no catch-all absolute application is going to result in some absolute catch-all result. It varies building per building. And if you want to study that article in greater detail, I recommend you go to the December 2020 ASHRAE journal for that article. Filtration and disinfection goes on to ultraviolet light technology, laying out UVC lighting. Requires engineering design considerations to maximize effectiveness and, for in-room applications, prevent occupant exposure to UVC light. You have to make sure that your devices are properly designed and laid out to meet the application for UV light to be effective as they can be. ASHRAE does state, though, what is very attractive about UV light is it states categorically that ultraviolet energy inactivates viral, bacterial, and fungal organisms, so they are unable to replicate and potentially cause disease. Well, if we go back to the Guide to COVID-19 pages, we also have access to the building guidelines. And if you click on any of the links from schools and universities, healthcare, commercial, laboratory, communities of faith, residential healthcare, or just simply residential and multifamily, those guidelines are there and are available and are great resources that we just don't have the time to start drilling down into those, as you can well see, as we're already at 50 minutes. And we want to take a few minutes here to see if there might be any questions. But I hope today's presentation has given you some understanding of how perhaps better to navigate the Epidemic Task Force website, the resources they offer, the deep resources they have to offer for not only creating buildings in the future that are healthier and reduce the risk of infection, but also guidelines for reopening existing buildings that needs to happen, that must happen as we move forward out of this pandemic. Thank you very much for your time. And are there any questions?
So we'll start with a couple that are in the chat. If you do have any questions, go ahead and put them in the chat, or you can unmute yourself and ask. So the first one from Steve Palumbo: do you expect the ASHRAE guidelines to remain in effect even after the majority of people have been vaccinated?
And my answer to that is yes. And in fact, that is already shown in the fact that the COVID-19 PDF offers the post-epidemic guidelines. And I think where the industry is going to be moving toward is let's do what we can to design, make sure that our buildings can meet the need today in pandemic, can be adjusted in the future to increase system efficiency when we're out of pandemic. But should we go into another pandemic, readjust and adopt those strategies from these developing guidelines for the future. That would be my prediction.
Okay, Jim Clare's comment along those lines. As the virus mutates, we are seeing different versions of the pandemic. I believe we will be living with these guidelines for the foreseeable future, even after we are all vaccinated.
Yeah, there's every reason to believe that.
And that is the only questions in the chat. So if anybody has any questions, you can unmute yourself now.
All
right.
All right. Well, I would just like to. Oh, yes.
Yeah.
Hi, I see ASHRAE does not currently have a position on bipolar ionization. Do you see them having one in the future?
I would think there's every likelihood. The CDC and ASHRAE have acknowledged that ionization is an emerging technology. I think they're waiting for some third-party tests to come back, and of which we're already beginning to see data generated from independent third-party tests that demonstrate that hydrogen and oxygen ions do neutralize or deactivate SARS-CoV-2. It was done for the airline industry. And so what the dynamic is between ASHRAE and our manufacturer, Global Plasma Solutions, I don't know, other than I know that GPS is a strong advocate of ASHRAE, and they're looking for some further findings for its discrete application for SARS-CoV-2, but the broader application for germicides in general. However, the physics demonstrate that one of the resulting byproducts of ionization technology is hydroxyl radicals, or OH compounds, negative OH compounds. And those compounds have the electrostatic force to draw hydrogen from nucleic acids, demonstrating that they deactivate germicides. And you can see that most readily, certainly on a cooling coil, a condensing cooling coil where the technology is applied. It'll prevent the growth of biofilm on that coil. It will not happen. So I don't know what might be causing any, if it might be a delay, I don't know. I think ASHRAE is just doing due diligence and making sure that if it moves forward with advocating the technology, it has all of the data it needs to make an objective statement.
Will you be covering that more in detail in future webinars?
Absolutely.
Thank you.
Yep, we have it on our schedule to do bipolar ionization April 14th. So we'll be sending out invites for that coming up.
Sounds great. Thanks.
Let's see, Aaron in the chat, is there plans for a building to be certified as meeting these, are there plans for the building to be certified as meeting these ASHRAE guidelines? Are there any financial incentives that you may be aware of by meeting them?
I am not aware of any authorized certification program other than ASHRAE offers the guidance checklist to make sure your building is operating in conformance to. The only financial stimulus package I'm aware of is the CARES Act for schools. And that has become a national mandate. And so that is available for school districts. But I'm not informed, and I should be, and I will be. In fact, it needs to be a focus of mine. What is the CARES Act, and how would educational institutions apply for funding to create healthier environments for our teaching community and students?
All right, thank you, Aaron. Are there any other questions? All right. If you do have any questions, you can feel free to reach out to me or Dan, and we will be more than happy to answer them for you. If you notice, I might have messaged you directly if I wasn't sure what your last name was. So please check the chat before you log off. It will be for your PDH credits and also for your rewards program. So every 3 sessions that you attend, you'll get $30 in rewards for some kind of gift card. So make sure, if you want to qualify for that, that I know what your name is. And that is all we have. Dan, anything else?
Thank you so much for attending. We hope you found the presentation informative. And if you think of a question a day, 2 days, a week in advance, don't hesitate to reach out. We'll make sure you get an answer. And thank you for your time today.
Yes, thank you. And I will be sending out a link to the video within the next week. All right, thank you all.
Thank you very much.